Okay, so in a previous video, I spoke about what to do in the case of having the integral of 1 over x minus a constant times the x minus another constant. And there is an integral that you would find on the standard table of integrals that gives a general solution to that case. And it's always great to use these general solutions. They're very, very useful, but it's very important for me to know where they came from. So in the previous video, I show where that came from. And if you're interested in knowing where that came from, I encourage you to watch the previous video. But the general result that we got is this. So the integral of something in the form of 1 over x minus some constant times x minus another constant equals, I've got my dx over here, equals 1 over a minus b, so this constant minus this constant, we don't have to change the signs, just as they are, times by the natural log of the modulus of x minus the first constant over x minus the second constant. So this is something you might see in your table of standard integrals. And if you want to know where this comes from, watch the previous video. It's just using partial fractions. You break this up into partial fractions and you integrate each one independently and you'll arrive at an expression like this. Okay, but now that we have this general result, we can use this result to solve more complicated integrals, such as in the form of this. So what we need to do is we need to try and get this integral into this form. We need to have x minus something times by x minus something else. So here we have a negative x plus something multiplied by an x on the outside. So this a represents a constant, just some constant. Okay, so we have to algebraically manipulate this to get it into the correct form. And once we've done that, we can just plug it into this equation, which again, if you want to see where it comes from, watch the previous video. Okay, so let's have a look. How are we going to get this into this form? Okay, let me write a nice big integral over here. Okay, so we have 1 over, okay, now we have a coefficient. We have a negative a coefficient next to this x. I want this to be a positive x with no coefficient. So I'm going to take the negative a out of this. I'm going to write here negative a. And I want it to be x minus something, so I've taken the negative a out. And I'm going to write the x first. Now that I've taken out a negative a, the x is positive. Okay, and because I'm taking out a negative a, I've got to change the sign of this 1, which is good because we want it to be a negative, to minus 1 over a. So I've just taken this a out. That's all I've done. And if you multiply this through, you'll get the same thing. You'll get minus ax plus 1, which is what we have here, minus ax plus 1. Okay, and that's, basically that's the hardest part. Oh, I forgot my x. There's an x over here as well, okay? So remember, there's an x on the outside. So I took the a out of the brackets, but remember, there's also an x over here. Don't forget that x over there. Okay, so let me just write this again to make it very clear, since I forgot to write my x there. Okay, so we have minus ax, x minus 1 over a. Okay, so we have one of these, but we need to have two of these. And we have this coefficient on the outside, which we don't want. So let's get rid of this coefficient by taking it outside the integral. So it's 1 over, it's a negative 1 over a, integral of 1 over, I've taken this out, x times x minus 1 over a. Okay, so now we're pretty darn close to having it in this form. We have one of these, we need one more of these. The problem is we need x minus something, and over here x is not minus anything at all. And that's exactly what you need to realize. X is minus nothing at all. So let's write that. Let's write x minus nothing at all. So this equals 1 over x minus nothing at all times x minus 1 over a. So now we have it in this form. Okay, we've taken the constant outside and we have this form over here. And I've forgotten to write all my dx's. So this should have a dx over here. I'm just really focusing on the integrand over here, but they all should have dx's. Okay, so now let's just integrate this, and we can integrate this simply by pattern matching from here. So I'm going to just scroll down. In fact, no, I'm not going to scroll down because I want you to be able to see this, see how I'm pattern matching. So I'm going to write it over here. Over here. Okay, so let's have a look. We need to write 1 over a minus b. So let's write 1 over, okay, what is our a? Our a is 0. 0 minus b, what's our b? Our b is 1 over a. Okay, so that's this part over here. And we write ln, and modulus of x minus a, which is 0, divided by x minus b, which is 1 over a. Okay, and then we just neaten this up, and let's have a look. So this is, we're going to, and this was a minus. It has a minus 1 over a in the front. Okay, so what I've done over here is I've put this into the formula, but I mustn't forget about this over here. Let me just change color for a second, because this is something that I've done before. Oh, I didn't change color. I wanted to change color. I thought I changed color, but I didn't change color. There we go. Okay, so this over here, I didn't write this out front over here. So this part that you see also needs to be times by this. Remember, we have a negative 1 over a out front, so we're going to times this by negative 1 over a. So let me write negative 1 over a times all of this. So this is 1 over this, so we just take the reciprocal, times by negative a over 1, which we don't need to write. But look what's nice about this. We have negative a over negative a, so this is just 1. We're going to times all of this by this, and we get 1. So now we're just left with this expression over here. Here's our answer. The natural log of x minus 0, well, that's just x, over x minus 1 over a, plus c. Okay, now we could actually make this look a little bit nicer. This kind of reminds me of gamma in special relativity, but we could write this a bit nicer. What we could do is we could times this by a over a. If you times something by a over a, that's just 1. It doesn't change anything, but it'll make this look nicer. So if we times the top by a in there, we get ax, and the bottom we'll get ax minus 1, because a over a is just 1, plus c. And there's our solution. So once we have, my writing is a bit all over the place. I'm not exactly used to this bookcom. But once we have this nice general solution, which you can get by splitting this up into partial fractions, as shown in the previous video, then you just pattern match if you can get your integral into this form. And that's always the case with integrals. If you have something on the standard table of integrals, you just go to algebraically manipulate the thing into a form where you can integrate it. And that's exactly what we've done over here. And here we go. And here's our solution. Okay,